Today's lesson is about the remainder theorem and the factor theorem. So our learning objective is, I can state the roots, also known as zeros or x-intercepts of a polynomial by dividing the polynomial by a proposed factor and looking for a remainder of 0 and repeating until completely factored. Okay, so these are the two theorems that we're going to study today. If a polynomial f of x is divided by the factor x minus k, then the remainder is r equals f of k. And the factors theorem says a polynomial has a factor at x minus k if and only if f of x equals 0. So we're going to find out what that means. All right. So the remainder theorem says if f of x is divided by x minus k, then the remainder r equals f of k. So when I write x minus k, this is in the factor form. So the 0 or the coordinates, I should say the coordinates are at k0. And when I'm switching between the point and the factor, these are opposite signs. Okay. And instead of saying f of x, we're talking about k. So this is another name for y. Okay, so the remainder is the y value. And we had that in our last lesson. Whatever we evaluate at is the y value. All right, so let's do an example. Use the remainder theorem to evaluate the function f of x equals 3x cubed plus 8x squared plus 5x minus 7 at x equals -2. Okay, so I'm going to use this using synthetic division since I have a 0. So x equals -2 is the 0. When I'm using synthetic division, I want the 0. So I set the 0 to the left. I draw my L. And then I put my coefficients in and I said, I see I have 3, 2, 1, and my constant. So I have no missing terms. So I'm just setting up my coefficients. So I have 3, 8, 5, and -7. So the process for synthetic division to check if this at x equals -2 is a true factor or not is to check what the remainder is. So I start by bringing down my first coefficient. I multiply -2 times 3 and I get -6. I add down 8 plus -6 is 2. I multiply -2 times 2 and I get -4. I'm adding down 5 plus -4 is 1. I'm going to multiply -2 times 1 and I get -2. Add down, I get -9. So after I'm doing my synthetic division, I'm looking at what's my remainder. So my remainder is not equal to 0. So my conclusion is that x equals -2 is not a 0, but we talk about it in terms of a factor. So this is really x plus 2 as a factor. Okay, so I'm going to say that x, so my conclusion is x plus 2 is not a factor. Okay, so I'm constantly talking about factors and zeros, and I need to know which one I'm talking about. Okay, so in this example, we said the remainder is -9. So another way of writing that is f evaluated at the 0, which is -2, equals -9. So the point on the graph would be -2, -9. I can verify this by substituting in my original function and evaluating at x equals -2. So I'm just evaluating here. So f at -2. So this would be 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. So if you're a junior taking the SAT, you don't want to be using your calculator because the evaluate questions are on the SAT. So -2 cubed is -8 times 3 is -24. -2 squared is 4 times 8 is 32. Minus 10 minus 7. Okay, so 32 minus 4 is 8. Minus 10 is -2, which is -9. So we said f at -2 equals -9. So we verified that. Okay, so this is seeing the same problem several different ways. All right, one more example. For the factor theorem, this was the remainder theorem. So the factor theorem states a polynomial has a factor x minus k if and only if f at x equals 0. So this is from geometry, so this is implying I have a definition. So it's true either way. And f of x, so this is saying that my remainder equals 0. So whenever the remainder is 0, k is a 0. Or another name for a 0 is a root. Oops. A root. Or an x-intercept. Okay, so whenever the remainder is 0, then k is a 0, root, or x-intercept. All these different words. All right, so let's do one example. Show that x minus 2 and x plus 3 are factors of f of x equals 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. Okay, so these are factors. So when I'm doing synthetic division, I want the zeros. So the zeros are x equals 2 and x equals -3. Okay, so I'm going to start out with, I'm going to use this 0, x equals 2. And I'm going to set up. And I have 4, 3, 2, 1, 0. So I have no missing terms. So I'm just writing in my coefficients. 2, 7, -4, -27, -18. All right, so I am starting out with my first 0. I'm going to bring down my coefficient. So 2 times 2 is 4. Add down, I have 11. 2 times 11 is 22. Add down, I have 18. 2 times 18 is 36. Add down, I have 9. 2 times 9 is 18. Add down, I get 0. Okay, so I'm looking for, to verify that x equals 2 is a 0, I'm looking for the remainder equals 0. So since my remainder equals 0, I have verified that x minus 2 is a factor. Okay. Okay, since I have x minus 2 as a factor, instead of going back and using the original coefficients again, I can just use the current coefficients that I have to check my next factor. So I can just set this up and work with these values as my next 0. Okay, so I'm in the same process. I'm going to bring my first coefficient down. Negative 3 times 2 is negative 6. Add down, it's 5. Negative 3 times 5 is negative 15. Add down is 3. Negative 3 times 3 is negative 9. Add down is 0. Again, I'm equal to 0, so my remainder equals 0. So my x plus 3 is a factor. Okay. And then it's asking us to factor completely and find the remaining factors. Okay, so what I started out with is this is at this level, this was x to the 4th, oops. This was x to the 4th. So this coefficient here is x to the 3rd. So this coefficient here is x squared, because I keep going down by 1 degree each time. So at this point, my equation is 2x squared plus 5x plus 3. And I need to factor this. So I'm setting this equal to 0. Okay, a is not 1. So I want to know what are the factors of 2 and 3. So if I just do some guessing and checking here, so I know the factors of 2 are 1 times 2, so I have a 2x and a 1x. I know from my plus 3 that my signs are the same. Since I have a plus 5x, I know both of my signs are positive. And then I want factors of 3, which are 1 and 3. So if I put 3 in this first factor and 1 in the second factor, when I check, I have 3x here and 5x here. So I have the rest of my factors. So it's asking me to completely factor. So putting all 4 of my factors together. So these are my first 2 factors, x minus 1 and x plus 3. And these are my second 2 factors. So rewriting everything completely factored is f of x equals x minus 2, x plus 3, 2x plus 3, and x plus 1. And we are done.